right up, ladies and gentlemen. What we've got here is the one, the only, Amelia's Weekly Fish Fry, brought to you by eejournal.com and hosted by me, Amelia Dalton. Did you know that the United States is the world's biggest target for cybersecurity attacks? It's true, with almost 38% of the world's cyber attacks aimed at the U.S. Now, what does the dollar figure here look like? Well, according to a 2018 study done for IBM, the cost of the average data breach to companies worldwide is around $3.86 million. But the cost of the average data breach to a U.S. company in particular, almost $8 million. Yeah, and even worse, they found that the average time it takes to actually identify a data breach is 196 days. Yeah, let that sink in for a second. So how can we turn around this whole situation? Well, that might not be completely possible, but there are some steps we can take as engineers, as consumers, that can make a difference. My guest is Cynthia Wright, Principal Cybersecurity Engineer at the MITRE Corporation, and we're talking about the many layers of cybersecurity and IoT, what the weaponization of everything is all about, and why privacy by design, security by design, and resiliency by design will play a vital part in the future of IoT. Let's get started. My guest today is Cynthia Wright, Principal Cybersecurity Engineer at MITRE Corporation. Thank you so much for joining me, Cynthia.
Thank you. I appreciate the opportunity.
Okay, so first off, for my audience who may not know, what is MITRE Corporation all about?
MITRE's a not-for-profit entity that supports the federal government with scientific and technology and policy advice in the public interest. So we don't make anything, we don't compete with industry. Any products we develop, we then transfer to the commercial world. We're all about trying to solve problems in the public interest in ways that the federal government can't necessarily afford to do internally.
So we're here at the MEMS and Sensors Executive Congress, and you jumped off with the keynote today. And we were talking specifically about how MEMS and sensors have the potential to revolutionize our society. But right now, we're hearing a lot about negative things have happened, including the MIRI botnet. Tell me more about that and some real-world examples that we're trying to solve.
Sure. The MIRI botnet occurred, I think, 2016 or something, a year or two ago. And it was an attack in which hackers broke into IoT systems like thermostats, refrigerators, things like that, and didn't attack the homes that those were in, but used those systems to form a botnet that they then turned against some major websites like Netflix and Spotify to do a distributed denial of service on those systems. So it was sort of an indirect usage of IoT devices to attack something external. So because Internet of Things devices, which rely a lot on MEMS sensors and systems, microelectromechanical systems and sensors, are increasingly ubiquitous in our homes, our light bulbs, toasters, refrigerators, all those things that you've been hearing about. People have been finding creative ways to turn those against their users. Lots of folks have heard about baby monitors being broken into and used to terrify parents. Thieves have also used internal laptop cameras and other cameras in a home to surveil a home before they rob it, find out when people aren't home. We've seen attacks on critical infrastructure. Fortunately, have not resulted in any damage yet, but we've seen malware injected that is meant to affect sensors and systems. The Aurora experiment with the Idaho National Labs demonstrated taking down an electrical grid substation. So there's lots of potential attacks of varying severity, ransomware in hospitals, other attacks meant to destroy rather than ransom. And a lot of those attacks are enabled by these Internet of Things technologies.
So you brought up a really interesting statement. You said the weaponization of everything. Now, tell me more about that. What do you mean exactly by that?
So that term comes from a Defense One article from a couple of weeks ago, and it was focused on the idea that modern warfare isn't necessarily going to take place through bombs and weapons and nuclear attacks, but more through undermining the foundations of a society. And increasingly, our technologies are the underpinnings of our society. They're in our cars, our phones, our health services, our civil discourse, our ability to notify the public and trust what's happening from our political leaders. The idea of the weaponization of everything was that sophisticated attackers, particularly nation-state attackers, can look to undermine the stability of our country, any country, whatever, by targeting social media, people's phones, what they're doing, what they're seeing. And a lot of those attacks are enabled by this ubiquitous sensing technology, where you are at a certain time, what you're doing, what you look at, what surrounds you. So the idea that the technology we invite into our lives, to the degree that it's unsecure, is enabling this kind of undermining of the fabric, or potential undermining of the fabric of our civic society.
Now let's talk about solving these problems. You talked about privacy by design, security by design, resiliency by design. Talk more about that.
It's definitely a problem we're solving. I would absolutely not advocate that we just eliminate all these technologies from our lives. They do amazing, phenomenal things, boosting economies, creating all kinds of capabilities in healthcare and other areas that we wouldn't have had without them. So it's absolutely worth solving. The MITRE Corporation is focused on systems engineering. We like to look at the entirety of a system, not individual components. And so when we talk about privacy by design, or security by design, or resiliency by design, we want to look at how a component is going to be used in the greater system. Not every toaster needs to be secure, or every refrigerator needs to be secure, but certain ones do. If you're operating a refrigeration system in a vaccine production facility, that's important, and those kind of systems need to be secured. So if manufacturers can look at those potential applications when they're designing their systems, there are a fair number of options for at least increasing the security of these systems, whether it's having, non-default passwords, or passwords that a user is forced to change, putting some encryption on board in those chips so that all the data that passes between the systems is encrypted, or whether it's some physical modifications that just make the chips a little bit more resistant to attack. There are many options. We typically say that cybersecurity is invariably cheaper and more effective when it's built in and not bolted on. The lower in the fabrication process we inject these improvements, the cheaper and more effective in the long run it's going to be.
So another thing you mentioned was beware of shadow IT. I love that term, and it absolutely makes sense. Tell my audience more about that.
So by shadow IT, we mean IT that you're not aware of. Everyone is aware of their computer as an information technology device, but may not necessarily, for instance, in your car, be aware of all the sensors and subsystems that make that up. So shadow IT is IT that's invisible to the user, but can have significant effects on how decisions are made, how operational processes are executed, how products are developed. Eliminating shadow IT, or being aware of shadow IT, is about understanding what components make up your larger system and what the individual vulnerabilities of those components might be, and applying some risk management principles to try to address those as early in the process as possible.
Let's talk a little bit lastly about some legislative ideas that are in the works. What do you have the most hope for? What are some real concrete things that could be happening that might actually help solve this on a standards legislative basis? So
personally, I would prefer that regulation not be the sole answer. My preference would be that government develop guidelines, effective solutions that manufacturers can then employ. So I think the legislation that seems to have the most promise are the ones that require transparency in manufacturing so that users understand what the vulnerabilities are in their systems, and that those vulnerabilities are visible to the user, and that government help develop the standards against which those are measured. For instance, NIST, the National Institute of Standards and Technologies, is developing a couple of frameworks to try and help manufacturers figure out how to do that. And I think that that's a good approach, where government sets the standards and industry applies them in a way that's cost effective for the risk management.
So one NIST thing that was especially interesting to me was the lightweight cryptographic project. Now tell me more about that, and my audience can submit ideas for this project, right?
Yes, that's right. The deadline for submissions is February of 2019. And the idea behind this project is that the microsensors that we're targeting in this idea, they depend for their functionality on the fact that they're tiny and have very little processing power. And yet, to secure them, we'd like them to do a little more processing, like encryption or password control or something like that. So NIST is trying to find ways to help manufacturers add encryption at the chip level in a way that doesn't dramatically increase cost or processing power or any of those other things that make MEMS effective. And they want to do that with industry's input. So they're soliciting anyone's input, actually. I have recommended in this discussion that manufacturers partner with their workforce development chains, with academia, with innovators inside their organizations who have ideas about how they could make minor modifications that would have significant security impacts, and then get those ideas into NIST and see if they can be integrated into the framework.
Excellent. This was super cool. Thank you so much for taking the time to speak with me, Cynthia.
Thanks very much for the opportunity.
Speaking of IoT, we all know that today's IoT designs rely on a massive amount of data from a wide range of different sensors. Now, one thing that most of these systems have in common is the need for high-resolution data converters that can operate on limited power budgets. But maybe you're not an expert in high-resolution data conversion. Yeah, me either. But, my friends, you are in luck. In a recent episode of Chalk Talk entitled Analog to Digital Converters, a Resolution Revolution, I sit down with David Andine from Maxim Integrated and chat all about the latest generation of data converters and how you can take advantage of them in your next IoT design. You can check out this episode of Chalk Talk by heading on over to the Chalk Talk section of EE Journal. Can't miss it, right across the top. Or click the link below the player on this week's Fish Frying page. Or you can also just head on over to YouTube. Keyword EE Journal. Now, hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If LinkedIn is more your thing, well, sure, you can follow us on LinkedIn as well. And our Twitter handle is EEJournalTFM. And we have that YouTube channel I mentioned earlier, keyword EE Journal. It is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series. And by clicking the links below the player on this week's Fish Frying page, you can check out the Fish Fry archive or subscribe to Fish Fry via the iTunes Store. And remember, if you want any further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's Fish Frying page. Thank you, everyone, for tuning in. If you know of any cool new technology, any fun EE conference coming up that I absolutely should attend, or even the best geeky hotspot in your city, I love that stuff. Shoot me a line at amelia@eejournal.com or post a comment on our forums on EE Journal. For the week of November 16th, 2018, I'm Amelia Dalton, and you've been fried.